Welcome to my channel. In previous lecture, I have discussed uh, bet first search BFS. In this lecture, I will discuss DFS means depth first search. Unlike the BFS, in DFS we traverse at the depth wise. Means if there is a this is our graph, or if we take a simple graph, suppose this is our graph, we will first traverse from the source node and then take a branch, and according to that branch we will continuously traverse that branch until a branch or a neighbor of a vertex is completely null. Means we will traverse this branch until neighbor of this vertex is null. When this is null, then it will traverse back to its previous vertex and it will check if its its neighbor is any neighbor of this node is empty or not. If empty, uh, means here not visited. If not visited, then visit those. If visited, then just backtrack at the source node. This is how the in BFS we will use this concept. Now let's take this example. This is our graph. We will perform depth first DFS. This is our source node. Before that, we will maintain a visited index to check if that graph is ever traversed or not. The number of visited index will be equal to number of vertex. So at initially all the vertex will be false. This is 0, 1, 2, 3 and 4. And here is the result where we will store the value, and also we maintain a stack. Now let's start from this node or this vertex. This is our 0, and when we visit, we make this vertex, we make this node as true, means visited this node. Then we will check if there is any neighbor of this vertex. If yes, then traverse, then go to its neighbor node. This is 1. So, and before that we will also, when we will visit this node, then we will store it into the stack 0, and also we will store it into our output, that is result. And after visiting the 0, we will go to the 1, because 1 is the neighbor of 0 vertex. So after that we will make it true, because we visited this. So also we will store it into stack and also push into result. After visiting this vertex, we will also check if there is any neighbor of 1, and also check that that neighbor is not visited. If visited, then just leave. If not visited, then go and visit that. So we will go to visit at 2 and we will make it 2, and we will push back into stack and store into result 2. Now we will check any neighbor of 2 is not visited, that is 3 and 4. So we will take 3. So when we go to 3, first we will make it 2 as a visited, and then we will store it into result, stack. This is our stack, and store it into result. Now we will check if there is any neighbor of 3 is not visited. If there is no neighbor or no node of 3, so which is not visited, so it will backtrack. So it will backtrack to 2. It will backtrack. It will backtrack, and also when it will backtrack, it will pop out from stack. So 3 will be pop out, and now at 2 number indexes, it will check that any neighbor which is not visited of 2. Yes, there is a neighbor which is not visited, so it will go to 4. It will go to 4 and it will make it true that it is visited, and also it will store the 4 in stack, and 4 will also go to result. Now if there will be check if any neighbor of 4 is not visited. No, every neighbor of 4 is visited, so it will also backtrack because it reached at the depth. So it will backtrack to 2. Also when it will backtrack, it will also pop out from stack 4. Now at 2 it will check is there any neighbor which is not visited. No, so it will also backtrack. So 2 will be pop out from stack. Now at 1 it will check any neighbor which is not visited. No, there is not such kind of node which is not visited, so 1 will be backtracked to 0. So 1 will be pop out, and also 0 will be pop out, and at last this result will be returned to main function. Now we'll write down the pseudocode. Now this is our DFS function where we will pass the adjacency list, visited index, and source node, and also the result. Now first we will make the source node as a visited as a true, visited of source node as a true, and then we will push back the source value in the result, and then it will check for every neighbor of source node, so that we will use the for each loop. Int I means all neighbor of the adjacency, all neighbor of the source. If now if visited of I is equal to false, means not visited, then just make a recursive call and repeat this thing until all node is visited. So for this is the for each loop, and after that it will return the result at the main function. So I hope you understand. Let's go to in practical. Now I have opened the VS editor where I create a DFS.c++ file, and I will just write the IOStream and vector I added, and using namespace. Now I will create the DFS recursion code. So here I will further store the adjacency list, vector int, and I will pass the value of adjacency, and another vector boolean of visited, and in the source, and the result. Now first at the source index of visited will be true, visited of source will be true, and then in result we will post back the value of source, and now execute write the for each loop to traverse every neighbor of a source, and it will check if visited of source, visited of not source, visited of I is equal to false, means not visited the neighbor. Then again call the DFS in recursion adjacent visited source and result, vector int DFS, where we will pass the adjacency, And by default we create the visited vector visited array according to the size of vertex. We make the and visited array, and by default at the starting all the indexes will be false, and we also create a result array means vector, and then we create a DFS where we pass the call the DFS and call adjacency where we pass the adjacency list, visited source as a 0, we make as a source, and result, and at last it will return the result. Now we will create another function which is void at h, where we'll pass the vector and source and destination, and adjacency of q dot puts back of v, and also we'll add the adjacency of v dot puts back of u. We make this is for the creating the adjacency list, and now at the main function number of vertex will be 5, and this is for the adjacency list, and size of adjacency list is 5, and first we create at the edges where we pass the adjacency list, and this is for the creating the list. After getting the adjacency list, now I will perform the DFS, and all the thing is stored in this result. And now I will call DFS and first just pass the value of adjacency, and for int I is equal to 0, I is less than the number of vertex I plus plus, and the out of result of I. It means number of result will be printed. Now let's run this code. This is because I think I have missed something. Make it 2 times. Now let's see this is here's the correct 0 1 2 3 4. It is the same answer in theory. So thanks for watching.